some words. Sup, Calgary. How?
Screen new space, that looks good. Oh, I'm just like Calgary, can you hear and see me? I think the camera's just like a tiny bit too low that I'm getting cut off right here. Oh my god. I'm very unprepared this morning. I'm sorry. I did not think it would take so much setup time to get my computer. Now I gotta mirror displays. I don't know. We'll find out. Calgary, can you hear us?
Calgary.
And what's the lag time? What's the lag time?
How would he know?
How would they know?
Oh, the video maybe.
Yeah. Okay. Wait. So if I count down from 3 to 1, and then as soon as I hit 1, you send a message, then we'll be able to time since I said 1 and when the message started. So it's not.
But how do you know the message not lagging?
Because I trust Slack's real time more than. Okay. So hold on. All right. So I'm gonna count down. 3, 2, 1. Someone in Calgary sent a message. If they didn't send a message, we're gonna look like idiots. Also, can you say something?
Hello?
Can you hear that?
Do you guys hear that?
Okay.
Hey.
13 seconds.
13 seconds?
Yeah, but they didn't send an emoji. Maybe he's replying to me.
Sup, Aaron?
Wait, is Aaron an instructor? Should I not be talking to him like that?
Hello, Aaron.
Oh, is Aaron typing?
Can you hear us? Sam's mic is kind of
Sam's
quiet.
mic is kind of quiet.
But mine's okay, right?
Yeah, it was pretty cold in Vancouver this morning. Yep. Is my mic louder now? Do I need to put it all the way up in like my face? Can you guys hear me okay? Do I need to speak louder into the mic so you can hear me better? It's really clear. Is that me or you?
Is that me? That's not me. Pretty out.
Okay, all right. I don't know. Someone is. I hate that I can hear my voice coming out of these speakers. That's awful. Turn them? I don't know. It's too much effort. It's already 9:08 and we still haven't started lecture. So how's everyone doing? How's Friday? How's Chatty?
Good.
You finished Chatty? Yeah, everyone finished Chatty? That's cool. Doing unnecessary stuff to apps is what software devs do. So, okay, right. Today, oh, well, I guess I should introduce myself to Calgary. Hi, Calgary. Yep, hi, Calgary. I'm Sam. I'm an instructor at Lighthouse, obviously. I just came in off the street. It seemed warm. There was free coffee. They let me sit down. No, Jesus. I really enjoy using emojis for stuff. I have keyboard shortcuts for emojis. That's jazz hands. Whoops. See right there. So I have like exclamation jazz for jazz hands, exclamation poop for poop emoji. The cool guy emoji. Yeah. So if you remember any of the week 5 content that had emojis, that was I played a small part in that. Is it bad practice to code with emojis? No, some languages actually let you do that, not JavaScript, but some languages will say, yeah, no, like I could do this in some languages. Right? Yeah, or like,
No way.
yeah, some languages. Can you imagine that like every time you wanted to do something later on in your code, like every time you wanted to console log, you just like,
That'd be amazing.
right?
Definitely help learning a lot.
That would help. No, that would not help learning a lot. Okay. All right. So what are we actually supposed to be talking about today? Prototypes. What are prototypes? Had something to do with JavaScript, that's for sure. Yeah. So we're not going to be doing any React stuff today, in lecture anyway, or WebSockets or any of that other stuff. It's actually kind of a cool one. Damn, I restarted my computer. Because it's like JavaScript fundamentals again, kind of like week 1 stuff, but in week 6. No, I don't want to. Yeah, you know, like in week 1, it wasn't how to build apps. It was like, here's how JavaScript works. Yeah. So everything since then has been, here's how to build apps. But now we're going back to like, here's how JavaScript works. That's kind of nice. Kind of nice. Okay, so before we can start talking about prototypes, let's talk about classes. Class. What is a class? All right, everyone at the same time, come on. In general? What was the beginning part of that sentence? I heard blueprint from one person. What were you saying there? You had like a whole sentence. It sounded good. Well, it's not an object in most senses, but it does give us some structure that objects can inherit. I kind of like the way you worded that part. Inherito. A blueprint, yeah. So classes can kind of be thought of as a blueprint. They give some sort of structure. And when you create instances of a class, it's right there. When you create an instance of a class, you get an object built from that blueprint. Blueprint. My hands are still cold from being outside. Did Calgary chime in for any of that? Nope. Okay. Almost. but not quite. It's almost like it's a prototype object was set in Vancouver. We should pass the mic around, that'd be funny. So, yeah, why don't we use a class or something? Let's create a class. Let's just get our JavaScript juices flowing. That sounds wrong. What should we create a class for? A duck? Class duck. What does a duck do? Guys are on top of this morning. Quack. Quack. No, I like class duck. Animals don't quack. Ducks quack.
That's true.
All right, you guys are like way ahead of me. Okay, so we could create like a class animal, and duck could extend animal. Yeah, sure, whatever. Extends animal. What does animal do then? We got poop in Vancouver. You got poop to beat, Calgary. Animals poop. No, they seem comfortable with that. There we go. What is quack? Yeah, we're not going to make an extensive. We're just going to do a couple of things here. So all animals I think can poop, and ducks I'm pretty sure all of them can quack. Can a rubber duck quack? It squeaks. So then we get into weird, like how do we inherit that, but also like change it so it's a squeak instead of a quack. But actually we won't get.
It'd be like sounds, and then it would extend like a quack voice.
Yeah, but then you can only extend one thing. So. Hey. Yes, you'd have to create a rubber duck that extends animal and not duck, and like this whole inheritance thing. Anyway, what does quack do? I don't know. Console.
Yeah, rubber ducks don't poop. Yeah.
Oh, that's true. So you want a rubber duck that inherits from duck but not from animal. How do we design our code? How do we do this object-oriented thing? What is? Let's see. Is there a duck emoji? Yeah. Oh, which one? We got like the mallard duck. That is not a duck. I mean, that one's cute, but this one's more realistic, I guess. So. Quack. Okay, so how do I create a new duck that can quack? Create a new object. How do I do that? I love your enthusiasm, but that is not how I would create a new duck. Oh no, we're not like creating a new class. Like I just want to create an instance of duck. How do I create an instance now? Const duck one. Should we give it a name? Larry. Larry equals new duck. Is that how you spell Larry?
2 R's.
2 R's. Isn't it weird to write it like lowercase though? Because it's a variable. That's weird. Okay, so then how do I make Larry quack and poop? Larry.quack and Larry.poop. Cool. So what's going to happen if I run this?
Larry will crack and poop.
Well, we hope so. Okay. Node 1. Larry quacked and Larry pooped. We did it. Yeah, we're not even 20 minutes into lecture and we're already making ducks quack and poop. Cool. So everyone understands classes and objects. Are there any questions or anything to do with this that people don't understand quite yet? Or if I told you to create a duck that inherits from animal and then create instances of that duck that quacks and poops, everyone would be like, yeah, cool, I got this. Cool. Then we understand classes. Sweet. Okay. So, did you know that classes in JavaScript don't actually exist? I think most of you know. All right. So, what is a class? If it's not Okay, so let me make this more concrete. If I was to ask what is the type of duck, what would it be? 'Cause it's not a class. Classes don't exist in JavaScript. It would be a function. And duck would have a property called prototype. That's where all the methods inside duck actually exist, so where quack exists. And the instance of duck would have a property called proto that is the same object as duck.prototype. So these two are identical, meaning that I could also tell Larry.proto to quack instead of just saying Larry.quack. How many quacks are we going to get? 1, 2, 3, 4. Yeah, look at all those quacks. Cool, so everyone knew that? Any questions? No, everyone cool with that? Yeah, so if we had a bunch of methods, not values, just if we had a bunch of methods, they would exist on these prototype things. They do not also have the properties of that object, but we will clear all of this up and kind of get an insight into what's going on here. So, what's up? Which one? Dot length. I would assume dot length is a function. So there's that idea of, and I don't want to go too far into this at the beginning of the lecture, but there's the idea of like getters. So if I had a getter that was a length that was actually a function, but it would appear to be a property. I've spelled length wrong. Yeah, exactly. But we can maybe get into that kind of stuff later on. Yeah, exactly. It's still okay. So let's dive into this. I will answer all of these questions and more by simplifying the hell out of this. So let's see, where are we? We're in classes. So classes are pretty important in a lot of languages. They are like the main type of languages like C++ and Swift and C# and Ruby, I'm pretty sure, which you'll be learning next week. And when we're looking at most languages, thinking of classes as this blueprint, as this thing we use to create objects from, is a pretty safe way of thinking about them. But in JavaScript, there is no such thing as classes. In JavaScript, there is no such thing as a class. They just do not exist. The class keyword is syntactic sugar around functions and objects, like all week one stuff. So what we're going to do today is look at how this system in JavaScript, this system of prototypes, how do prototypes work in JavaScript? So since JavaScript has this class keyword, and we can use classes kind of like we can in a lot of other languages, why would it be important for us to learn how prototype? Is that me or is that me? Yeah, if we can use classes, we've used classes all week. If we can use classes in JavaScript, why would we even bother to learn about this prototypes thing, like stuff under the hood? If I can just come in here and create classes and pretend that classes do exist in JavaScript. Because prototypes are how JavaScript actually does this, but like the reason the class keyword was introduced is so I didn't have to deal with prototypes. So I could just pretend that there's no prototypes, it's all classes. And that way I can switch from languages like C++, C#, Swift, JavaScript, and just be like, classes, cool, I know how to use those. So you can make custom methods, maybe, yeah, I guess. Like if you wanted to extend behavior of like built-in things, like you create a custom method for array, if you know how to use prototypes. Sure, it kind of helps with that, but I don't think most people want to be doing that stuff. And like most of what you do want to achieve can be done with classes. You're kind of ignoring how JavaScript works. Yeah, but that's like the reason class was introduced. Is because people wanted to ignore all that stuff about JavaScript. Let's ignore how prototypes work. Let's just pretend classes are real and let's just do that. Because classes break down, you have to understand prototypes to fix that breakdown.
Classes are in fact syntactic sugar over prototypes.
Oh, oh wow. No, Joel, you just blew our mind.
So as a result, classes are a leaky abstraction over prototypal inheritance. It's not real class inheritance.
Yeah, but like...
prototypal. So what ends up happening is that every now and then when you're using classes in JavaScript, and you can't expect them to work the way classes work in other languages, so sometimes you have to get back to the fact that, well, really this is just a thin layer of lies over prototypal inheritance.
See, I was kind of expecting someone to go on a tangent just like that, and then I was going to shut it down, saying, no, well, no, that's not a bad argument. I have a better argument for why you should learn prototypes.
That's a good question.
So, like, what?
That's a good question. Sorry, you had a good question. That's a good point. I'm not sure where exactly where
Joel's talking, Calgary. There's a mic, you can pick it up.
What's your point, Sam?
Okay, so my argument is, in many languages, to do OO, to do object-oriented programming, you use classes. That is the way you do it. In JavaScript, there are many ways to do OO, and on top of that, there is no correct way. I'm going to write this. There is no correct way of doing OO in JS. Capitalize those.
I like how part of that could be like, hey, some would be like, there's no wrong way to do OO, but the truth is there is no right way to do OO.
There is no right way. So if you're using classes, fine. Is that the right way? No. Is it the wrong way? Meh. But you can use classes. You can use prototypes. You can use just literally object literals that you learned how to use in week 1, and all of that is fine because none of them are correct. I see how it's glass half empty now.
None of them are wrong.
If I could have a perspective on that, basically JavaScript is a procedural language that has like 20% of the features you need to do 80% of functional programming, and 20% of the features you need to do like 80% of OO. And it's just that after, if you really try to push that to do like other class-based things, it just breaks the fuck apart. I love you, Sam.
That was nice poetry by Joel.
Hi, Joel.
Thanks. I've forgotten where I was. Yeah, Joel tends to do that. Oh, that was funny. Okay. What are we talking about? Right, yes. Okay, so kind of what... Yeah, it's going to happen a lot. Kind of what Joel said, mostly what I said. Classes are a leaky abstraction, but they're good enough for a lot of companies, people, frameworks like React to actually say use just classes. Don't worry about prototypes anymore. But they're not solid enough that we can just trust that they're always going to work. So knowing how they work under the hood can be helpful. But also, like I said, there isn't a correct way. So using classes isn't always the correct way. And if you want to use prototypes instead of classes, go nuts. If you want to use object literals like we did in week 1, cool, that's fine. So with that in mind, let's play around with some objects. But before we do that, there is one question that I want us to be able to answer by the end of this lecture, and that is, how does property lookup work in JavaScript? So when I look up a property on an object, what is going on? So let's create a new file, and let's create some objects, just like we did in week 1. Who's got an object for me? I mean, sure. Like Calgary, if you wanna make sure we don't keep using ducks, you can chime in with an object whenever you want. Goose. Yeah, we got duck. We got goose. Chicken. You guys are really into your birds. Penguin.
Whale.
They're just listing birds now. Oh, what is that?
Okay, we're doing it.
What is that? What?
All right, we're doing it.
How do you pronounce it? Ocelot. What, you guys know this is a common thing?
Roll in the streets of Vancouver.
Oh, right, that's what those are. I was wondering. Could have been an ocelot. Are they just like these cute little kitten-looking things? They're like tiny. Look at this guy. Look at that ocelot. Okay, I think ocelot wins. So ocelot, sweet. What does an ocelot have, or do, or things? It what? It naps. Okay, we can have it naps. Wait, how do you do this? How do I create? I think it's this way, right? Yes. Okay. Remembering my JavaScript. I can JavaScript. What happens when we nap? Or when the ocelot naps? We're just gonna do a bunch of console logs. Console log ZZZ emoji.
Oh. Oh.
Yeah. Oh, right. Yeah, I was not kidding at the beginning of the lecture. You mean like the week 5 content where you had like the comp sci emoji tree and oh, you know the vampires? Yeah, that was me. I mean, I can't take full credit, but I will. So if an ocelot naps, what's going to happen? Zzz. Boom, look at that. Cool. So if we create an object and we give that object a function, also called a method, when a function is a property of an object, it's called a method. Hi, Don. When we call that method will get invoked. Cool. No surprises there. What happens if I try and invoke a method that does not exist? So like, I don't know, E. Undefined. Undefined is not a function. Then what will happen? That's what I meant. Eat is not a function. Eat is not a function. All right. So some people said undefined. Some people think reference error. Type error. Sure. Error. Yeah. It blows our application. We get that error. So that's kind of a big deal. We don't want to crash our application. I guess we could do it in like a try-catch, but that would be kind of unnecessary. So we know that if we call a method that exists, that method will get invoked. If we call a method that does not exist, we get type error, whatever is not a function. So let's try a different method. Let's try toString. Does toString exist on Ocelot? Where? Yeah. So does it exist on Ocelot though, directly?
No, but it's a JavaScript function.
JavaScript function, maybe. We're trying to figure out how property lookup works. We know that based on our current experiment, if the object has that property, cool, we just like use that property. If it doesn't have that property, we try and invoke it as a function anyway, we get a type error. What is going on with toString? Like, first of all, let's run this and see what happens. Nothing, because it didn't crash, but toString also doesn't console log anything. So we can assume that this worked just fine. Why did it work just fine? toString doesn't exist on Ocelot. Where does toString exist? So one theory is Ocelot is inheriting from object.prototype because it's an object. Lots of things in JavaScript already have built-in methods that are just associated with it. So if I wanted to actually check it, so maybe Ocelot actually has toString injected into it at some point, we could check out, Ocelot's, what is it? Object.getOwnPropertyNames. Whoops. Will give us all of the property names of Ocelot. So if Ocelot did in fact have toString in here, we should see it get logged out here. It doesn't, it just has an app. We're getting to it. We're getting to the prototype. Okay, any other theories before we go to object.prototype? Yeah, so I was asking, does Ocelot have toString? So toString does not exist on Ocelot. We know that, so it must exist somewhere else. So when we're dealing with objects in JavaScript, every object does actually have a this thing called a prototype. And when I'm talking about this prototype, I'm going to use this syntax, prototype. Actually, I'll probably capitalize the P. Because there are different syntaxes actually used within JavaScript. There is __proto. Dot prototype exists on a function. There is things like object get prototype of. These are all things that I could write into JavaScript, and these are syntactically correct JavaScript. So when I'm talking about the idea of a prototype, and when I like write that down anywhere, I use this kind of syntax. That wouldn't work because an object doesn't have a dot prototype. Let's find out. Let's experiment a little bit. But first, so every object gets a prototype. Every object has this idea of a prototype, has a prototype. What is a prototype? A prototype is an object. Not even a secret object, an object. A object. A prototype is an object. So if you create an object, that object will have a prototype, which is just another object. It's just objects linked to other objects. It's, hold on, just objects linked to other objects. Not everything, no. If I type, for example, so the question was, is everything in JavaScript an object? Is this an object? No, one is not an object. However, can I write one toString? Which I could only do to an object. And actually, I'm pretty sure I have to put it in parentheses, otherwise this will crash. Or dot dot. Oh, right, yes, the dot dot one. Let's do it with a string instead, because that's nicer. Is a string an object? No, it is not. So I cannot invoke a method on it. But can I call toString on a string? Yes, I can, because JavaScript will convert it or create an object from that primitive type just so I can do this. So no, not everything is an object, but like JavaScript might, you know, just so you can do stuff. Yeah, that's fine. Kind of like just creates a new object based on that thing. Yeah. Anyway, so every object has a prototype. A prototype is an object. So like we're dealing with the most basic sense of objects like this, right? Like var obj equals empty object has a prototype that is another object. Like just object literals, just like we were dealing with in week 1. But what's up? Did someone say something? Oh, okay. Any questions? Anyone want to say anything? No, because it only turns it into an object when it absolutely needs to be an object. If I add 2 numbers together, no objects are ever created. It was kind of a side tangent just to answer the question, is everything an object? No, but JavaScript. So we have, every object has a prototype. Prototype's just another object. So we've got these objects linked to other objects through this thing called a prototype. But what does that mean? What does it mean if an object has a prototype? Doesn't mean it has a blueprint. Nothing to do with blueprints. In fact, as soon as we realize classes were not a real thing, we kind of throw out the idea of a blueprint. And we bring in this idea of just objects linked to other objects. So we could potentially have a prototype that you could link objects to that would have all of like the typical, what do you say, typical? Prototypical descendants. Yeah, I feel like we're just getting too wordy at this point. What, prototypes or? Okay, so there's this idea of descendants. I might get on the whiteboard for this. Can we see that? Do I have to switch? I will have to switch the thing. This idea of descendants that you get in object-oriented programming, especially when dealing with classes. But that kind of seems cool. It's a little bit more simple than that in JavaScript. It's a little bit more simple than that. So I'm like in. Oh, that was awful. Okay. We should have asked Don how we turn these off, because he would know. So, okay, so let's say we have an object. I don't know, what's an object? Let's pick a new object. Potato. We have a potato. I don't know what property a potato might have. It's yeah, I don't know.
Skin?
It has a skin method. Yeah, sure. Potatoes can grow. Potatoes. I don't know. They can like get mashed. Yeah, like you tell that potato, hey, get yourself mashed, and then I don't know, it does something. Sure, why not? Object-oriented programming, why not? Okay, so if I'm JavaScript and I try and look up the property get mashed on potato, I look at the object potato, I see there is in fact a get mashed property, so we're done. I just use that method. Now, if I ask potato for something that it doesn't have, what is something, I don't know, more generic, I guess? Actually, let's just be weird. Let's say the duck object has quack. So I ask potato for quack. Well, potato doesn't have quack. So what does potato do? It goes and asks its prototype, which is just another object. So potato goes and asks its prototype if it has the method quack. And if the prototype does have quack, then we get to use that quack method. So if we just said, hey, potato, your prototype, just going to use this syntax, is in fact a duck that does have a quack method, then I can call quack on potato. Because what's going to happen? Well, potato, do you have a quack method? No, I don't, but hold on, let me ask my prototype. My prototype's duck. Duck, do you have a quack method? Sure. Okay, can I use it? Yeah. Okay, so now we use this quack method. This is prototypes, and they're literally object literals. No, because duck would have to point back to potato as its prototype, and you cannot have a cycle in the prototype chain. Yeah. Only potatoes can quack. But then let's say we call a different method that doesn't exist on either of them. Then what happens? Let's say we call toString. Potato doesn't have toString, so it asks its prototype, hey, duck, do you have toString? No, duck doesn't have it. So then where does duck go? Where's duck's prototype? In JavaScript land? So there is an object that gets created. We'll see it is object.prototype. We'll see why that is later on. But there is an object that has some methods in it like toString and a couple of others. No, like a couple. Yeah, like a couple of others. A few others, maybe like 5, 6, or 7 others. Yeah, less than you would think. But it has these methods like toString. And when you create an object and you don't manually specify its prototype is this object. Oops. So we said potato's prototype is duck, but we didn't say what duck's prototype was, so it just defaulted to this object. So now if I ask potato toString, well, it doesn't have it, so it's going to check with its prototype. That doesn't have it, so it's going to check with its prototype, which does, so we get to use this version of the method. Okay, everyone with me? Any questions? When does it stop? Okay, so let's say we ask for a method that doesn't exist on any of these. Essentially, a prototype must be an object. So an object has a prototype, which is another object. Or, no. Right on the end of the board, no. So you can assign an object's prototype to be null, meaning you have stopped the prototype chain. This default object that has toString, its prototype is null. So whenever we call a method and it doesn't exist on the current object, it doesn't exist on the object's prototype, we get to null, and that's why we get whatever that, what was that error message that we got? Type error. this is not a function because we're trying to call it on null. Like that's why we got that error. So the end of the prototype chain is null. Is the same one? No. That's, I'm not sure what object.anonymous is. I think it's because we haven't named our object. We just created an object literal, so it's an anonymous object, which is not that important right now. Just looking at the error message that Calgary can't see, so that's probably annoying. Cool. Any other questions like that? That was a good one. Where does the prototype chain end? I hate these speakers. Would you write what? Yeah, okay, so let's take a look at some of the syntax for that. Let's change the camera back. Cool. So, there are different ways of accessing an object's prototype. Why, thank you. I think that's yeah, that's good. Yeah. So there are different ways to actually set an object's prototype. Let's go back into here. We have our ocelot. Is that it? What it's called? Yes. Ocelot. Yes. And let's say we want ocelot's prototype to be a duck. And a duck has a... All right, I was going to see if anyone's going to do something different. That's fine. No, no, no. They're completely separate objects. At this point, like, this is an ocelot, this is a duck, and then we're going to get weird. There's no inheritance. There is this prototype thing, but we're going to get to that. We haven't. Yeah, so we just got objects. We got a duck object and an ocelot object, and they are completely separate. And what am I going for with this? Quack. See, I'm gonna. I have an emoji keyboard that lets me do this quicker. Duck. Cool. Okay. So I got my ocelot and my duck. I hate this microphone. Let's get rid of these two, and let's say I want to duck.quack. Cool, no big deal. Ocelot.nap, duck.quack, ocelot.quack. Whoa. Okay, will this work right now? No, absolutely not. I have, like, you know, week 1, day 2 kind of object here with a function, whatever, like a console log z's, and here I have a duck, and they're completely separate. And this is really the only weird line in my whole code. So, let's run this. Whoa. So, we nap, then we quack, and then we realize that ocelot.quack is not a function. Based on what we know, how can I make this work? Yeah, right before we call this, any time before we call this, I can make ocelot's prototype be duck. Right now, ocelot's prototype is that object that we spoke about earlier that has 2 string and stuff, but I can change that. And there's a couple different ways of doing it. The not preferred way is to write __proto__ equals, and then set the prototype this way. So I could set ocelot's prototype to be duck like that. That's it. It's now, yeah, go ahead. JavaScript will fail before it even runs the code. Yeah, it will not put up. So the question was, what happens if I set duck's prototype to be ocelot? JavaScript will not allow cycles. Not because, okay, the reason I think is kind of lazy. Like, doing prototypes this way, objects linked to other objects, is a really easy thing to implement. But then as soon as you have to deal with cycles, you have to think a little bit more and make sure that you don't end up with endless cycles. So the creators of JavaScript were like, nah, we're not going to deal with that. Let's just... App crashes if we try to do that. I'm just going to not move. No, I've tried doing this with a mic before. It doesn't work. This mic? Wait, is it... Oh, you think it's this one? Is that it? Am I done? Let's see if the issue persists. Anyway.
When you write that prototype, you can write it in those 3 different ways as well.
Okay, so the preferred way of actually, so if I use __ proto, like say it's not the preferred way of doing things, but I'm going to do it during lecture because it's much easier to write. If I want to set, I would just do equals to the right of this. If I wanted to read it, I would just put an equals to the left of it. Instead, you're supposed to say object.get prototype of Ocelot if I wanted to get the prototype, or object.set prototype of Ocelot. Hey, look, there's a Franklin. Duck. Okay, so here's how you should actually set or get the prototype, but the syntax is just a bit more verbose. I'll put it in the notes.
Yeah. You can write it the second one because I've seen it with dots. That's the word.
Dot prototype is a different thing that we will get to later. Yeah, it's a completely different thing, and that's where it gets all confusing. So you got to deal with this dot proto, this dot prototype, and the idea of prototypes, and it's like. But every object has a prototype that we can access through __ proto or the other ways, and we can set those to be whatever we want, as long as it's another object. So if I run this now, what do we expect to happen? It still happens. It wasn't the microphone. Yeah, we can, the ocelot can nap, the duck can quack, but the ocelot can now quack.
What?
Yeah. What? The ocelot can quack. Make vodka. Wait, what makes vodka? How long ago was that? That was 10 minutes ago.
It's probably like what object?
Oh, out of potatoes make vodka. That's way better than get mashed. Damn it, Dave.
Oh, man.
Anyway. Oh, that's fun. Okay, let's even take this a little one step further. Let's assign some state to these things. What should Ocelot's state be? Like a name or a type or a color or a shape? Or happiness level? Favorite emoji? Nap. I just want to give it some state so we can see how that would work. Okay, so the ocelot state of awake is false and the duck state of awake is true. Sure, I'll go for that. Sure. So when we console log these things, we're also going to console log the state. So this dot awake. This dot, yeah, awake. Okay, so pretty simple, these first ones. If I say ocelot.nap, we're going to get all the z's, and ocelot is in fact not awake, so we should get z's false. Then we tell the duck to quack, we should get a duck and then true. When I tell the ocelot to quack, what is awake going to be?
True.
Because ocelot has an awake property that is set to false, but we're using duck's version of quack. So what is ocelot.quack going to be? Yeah. Will awake be true or false? Will we get ducks awake or will we get ocelots awake? They think it might inherit the method but not the property, meaning that it would take its own version of awake, which would be false. Or, since it's inheriting the quack method, it's also going to inherit, I hate using that word, it's also going to use duck's awake property, which will be true. So who thinks false? And who thinks true? And who didn't raise their hand? Sweet. Oh, we've got ocelots quacking. It's,
What an ocelot is? Yeah, it's a wildcat. How do you know these things?
because Joel knows everything. It was false. Yeah, so we get to use, like, when you use the prototype's method or property, you don't have to use every single one of its properties. So when you're using this within a function like this, within a method, it is going to refer to the object that this was called on. So it's going to ask the ocelot, hey, do you have awake? And if you do, we'll use that. And if ocelot didn't have awake, then yeah, we could use the duck's version of awake. Okay, so this is all there really is. It's just objects linked to other objects through this kind of prototype idea. And when we use classes or construct functions or anything else, this is what's going on under the hood. So we never even have to use classes. We could just use objects and link them up through prototypes, and that would be the end of it. Then why don't we? You think this is really more difficult to use than a class? It's just objects linked to other objects. Maybe a class is nice to read. I think maybe like a lot of people agree with that. That's probably why we have classes. But even when we create classes, we end up with these objects that are still linked to other objects. So anyway, are there any questions about what we've done here so far? Does any other language have prototypes like JavaScript has prototypes? I don't think so. I'm pretty sure JavaScript is very unique in the way it handles objects. Like a lot of languages, you need to create a class, and then you can only create an object based on that class. And then that object will always have, you know, like if we look at this, number one, if we had a class animal, we could only create objects from classes like animal, which means once we create an object from animal, we know it definitely has a poop method. We're like 100% certain that it has a poop method because we created it from animal. In JavaScript, we can just create objects on the fly. I can just create an object that has a poop method. I could create an instance of animal and then remove the poop method. I can do whatever I want in JavaScript. And no other language that I know of is that dynamic.
You're saying that in other languages you have to create, you can't just create an object by itself.
Yeah, exactly. Exactly. In other languages, in most other languages, you can't just create an object on the fly like you can in JavaScript. You must define a class, then you create an object from that class, and then you know that that object will always have the... Yeah, always have those methods. Like in this case, if I create an object from animal, it will always have a poop method, and I can be like sure of that. In JavaScript, obviously I can't because I could just come in here and, yeah, Larry dot, what is it, quack? There's nothing stopping me from just deleting that. Or putting in other methods, you know, I could completely change the interface. In other languages, it makes a lot of sense because you know that it has this interface, and you know that if you pass an animal to a method, you can definitely call poop, and it will definitely have these methods, and it will act this way. In JavaScript, it's just like, all bets are off. So I think thinking about programming in this way in JavaScript is kind of dangerous because it's trying to fit this class kind of way of programming into this really dynamic language. So that's why I generally prefer thinking of things in just these object sense, because this is all that's going on under the hood anyway. Just objects. And I can create objects on the fly and then link them to other objects. No big deal. Cool. All right. Any questions? Should we take a break?
Yes.
What time is it? 9:55. Okay, let's take a 10-minute break, and when we come back, we will potato. Yeah, it was for potatoes. We'll talk about construct functions, which is what you guys are going to be working with in your assignments today. Maybe we'll have a potatoes constructor function. Exactly, exactly. So that makes...
Yes.
So now we won't get any of that feedback and it won't be weird. I won't have to listen to myself. You guys don't even have to listen to me now.
Yeah.
Well, you'll still hang out here. Is your what?
We always listen to ourselves. But like, yeah, we talk to this actually. Be listening to ourselves. You talk about like your voice goes to your ears, but like without speakers.
Oh, yeah,
We
okay.
actually listen to ourselves.
Yeah, so okay, but
But not from an external source.
but not amplified. I had amplified. All right, everyone in Calgary, you guys back from the break? Back from break? Yeah. Gotta wait 13 seconds. I gotta figure out. Ask a question and then wait 13 seconds. Oh, all right, sweet. They're good to go. All right. What were we talking about before the break? Okay, so could everyone answer this question? How does property lookup work in JavaScript? Can anyone not answer this question?
Oh, I thought you said, can anyone not answer?
I did ask that, and then I pointed at you.
Okay.
Because, what? No, I'm talking about, like, just prototypes. So the answer to this really is, if you look up a property on an object, and that object has the property, like in our potato method that was get mashed but should have been make vodka, if we ask an object for a property, and it has that property, we get to use that object's property. But if it doesn't, it will then ask its prototype if it has that property. Sure, it's kind of like, if you want to think about it as a linked list, fine. Is it a linked list? I guess it is. Yeah. Yeah, okay, it is a linked list, good job. It is a singly linked list. Yeah. But that's an interesting point because we think of a linked list as very linear, not as this hierarchical structure where we inherit things and we have superclasses and things like that. It's just very flat. So that's really all that's going on. We have objects linked to other objects. Yeah, if we did this with people, it'd be like if someone asked me for something like, hey Sam, do you have a pen? But I don't have a pen, I could then ask another person for that pen. Like let's say Joel is my prototype. Hey Joel, do you have a pen? And if he has a pen, great, he'll pass it to me and I'll pass it back to you. But it's this very like just objects talking to other objects, objects linked to other objects. Things to remember are if you look up a property on an object and it does not have that property, it will ask its prototype. And if that prototype doesn't have it, it will ask its prototype and it will go all the way to the end of the chain, which will be null. Okay, any questions about how property lookup works in JavaScript? Pointers. Yeah, all the objects are pointers. But we won't get into that. Cool. So everyone understands how 100%? All right. Feel free to ask any questions at any point. So, what are we dealing with here? Okay, so if we look back at our example for Ocelot. Is that you said, Ocelot? Yeah. Keep wanting to pronounce it differently, like Ocelot. Ocelot and ducks. This is essentially what's going on behind the scenes. And if you are using just plain old objects and assigning prototypes, you can do everything. You don't need classes, you don't need constructor functions, you don't need anything else. You can do everything just with the plain objects. In fact, you could do more with this than you can by using classes and things like that. But some people don't like just using plain old objects and hooking up prototypes and thinking about it this way. So we ended up in JavaScript with a bunch of different ways of doing this, a bunch of different ways of creating objects and linking their prototypes. And before we had classes, this was done through constructor functions. Let's talk about that. Constructor functions. Okay, can anyone tell me what a constructor function is? A function that constructs. What a what? Oh, he stole your answer? A function. What is a constructor function? How would I write a constructor function in my code right now? Yeah. What's that? How do I define a constructor function? Like, I want to make a constructor function. How do I do it? Function. What's the name of the function? What object should we be dealing with? We had ocelot, we had ducks, we had potato. Vodka?
Well, yeah.
I just said vodka.
What does vodka do?
What does vodka do?
Nothing.
It makes you drunk. I feel like this is too much for Friday morning, guys. Come on.
What's another animal?
Coffee. I kind of like coffee. Coffee's good. Coffee's relevant. I once did this lecture on 420, and we ended up with weed cats. Yeah.
Ocelot duck.
Ocelot ducks and weed cats. That's what.
That's a fight I want.
That's what. That's a fight you want to see. All right. Cool. So we create a function. We call it coffee. Is there anything special about this function? Is there anything different about this function than what you've seen with normal functions? Yeah, I have used a capital letter here. What does that mean in JavaScript? It means nothing. This function is just an ordinary function that I can call as an ordinary function. However, what I am implying to any developer that uses this function is that it's a constructor function, which means that I want developers to use the new word, the new operator with this. But it is just a normal function. If I did something normal, like console logged, I don't know, coffee, boom. That's a weird emoji.
Whoa.
Yeah. If I just called coffee and console logged coffee, we would see it's just a normal function. Very normal. Nothing special. It's just console logged coffee. It showed up, I don't know, it showed up, I don't know. Yeah, and if you go on Windows, it shows up different. If you go on, yeah. But I want this to be used as a constructor function. Now, what do constructor functions do? If I use the new operator before calling a function, what happens? It makes a new object. So what happens is a new object gets created, a new empty object. So let's just pretend that we are doing what new would do. So we create a new object. I don't know, I'm just going to obj. Okay. We then set object's prototype. Sorry. Its prototype to be coffee.prototype. Now this is a little bit annoying, the naming here, and a little bit weird what's going on, but we'll come back to that. And then we return object, obj. We also make sure that this evaluates to the empty object. Which means that a new empty object gets created, and if I use this within the function, it refers to that new empty object. Okay. So if I call coffee with the new operator, this should happen, meaning that I can create a new instance of coffee, I guess? A new, like, I don't know. Would we have a different name for that? Coffee? Cup of coffee? Ooh. Yeah, all right. Cup of coffee. That works. Fine. Whatever. And let's just, like, we're doing the new stuff, so I'm just going to put new in front of it because we're actually manually doing all that stuff. So this is what's going on, which means that cup of coffee is this object that gets created when we use the new operator with a function. Okay. Every function, this is the part I kind of hate because of the naming, but every function, almost every function, because fat arrows don't get this, has a property called prototype. Which prototype? Boom. Okay. Every function has that property called prototype. So if I create a function using the function keyword anyway, like this, it will have a property called prototype. It will have a, wait, what did I say? Yeah, property called prototype. This is a badly named property because it gets confusing. It's like, what is this? It doesn't mean that this is the function's prototype. It literally is just an object that exists on new coffee that is accessed through .prototype. Anyway, this. Yeah, so new coffee is the function, but functions are objects. So a property gets assigned to this function called prototype, which is an empty object. So it's as if someone did this. Like, we'll create a property on a function and call it prototype, and we'll set it to be an empty object. Cool. I mean, like, whatever. We'll see how this might be useful in a moment, but that's what's going on. So every function gets this prototype property that is an empty object. And every time we create an object using a constructor function with the new operator, that object's prototype gets set to the function's .prototype. You can see why I hate the naming here. Yeah, it's like, Yay, JavaScript, right? Like, this is what's going on. It's like, ugh. Anyway. This is fun, right? Why did they invent this kind of syntax? It's just so we could literally write the new keyword with a function and have it feel like we're actually creating objects. So have it feel like it's creating objects using classes, because usually we use the new word with classes. So this.
With a new, is that capital C just full? Like, would it work if it was, would it throw an error if it was a lowercase c?
Nope, absolutely not.
Okay, so it's just for.
It's just.
It's not actually syntax. It's for the developer.
It's for the developer. Like, this is telling developers, hey, you should probably use this with the new operator because that's how I intended it to be used. So this is kind of what's going on under the hood. Let's actually see. I'm going to cut this out and put it in the notes. Let's see how you might actually use this then. So if we had a function called coffee, we can create a cup of coffee based on coffee. So if I console log cup of coffee, what's that going to be? An empty object. Why is it an empty object? Yeah, I think about summarized it. The function coffee, when used with, when the new operator is used with it, will create a brand new empty object and then return that object. So yeah, cup of coffee should be an empty object. Let's see, is this 3? Yeah, it's a new empty object. We do now get a name on that object though. That's kind of nice. So we do know that it was created from a constructor function called coffee. I guess like something within Node does that. So how would I modify what cup of coffee is within the constructor function? How would I give that some sort of state, maybe? Create properties on like the new object it creates, right? So we know this creates a new empty object. Creates a new empty object. How do we access that new empty object from within this function only when we use the new operator with this function? This. This, inside the function, when the new operator is used, refers to the new empty object that was created. The new empty object that will be returned from this function when the new operator is used, meaning cup of coffee in this case. Some people are like, yeah. Some people are like, yeah. Know that this will change depending on whether you use the new operator or how you use functions, or like, you know, a million different other things will affect what this is. But when used with new, this will be the new empty object that's created. So if I want to mutate this empty object, if I want to give this object properties before it's actually returned from the function, I would add those properties to this. So maybe this dot, I don't know, what does coffee have? Sorry, I was checking with Calgary and that was funny. Reading this channel is like the stream of consciousness of Imja. Slow Loris. Anyway. Okay, yeah, what would coffee have? What is a slow Loris?
Oh my god. Look up the slow Loris.
We'll look it up later. We'll look it up.
Oh my god.
Coffee does not have a slow Loris. I mean, I guess we could create a slow Loris constructor function, maybe. Maybe if we have time. What does coffee have? Cream? What should cream be? maybe cream true. Did you say absent? Wait, cream should be false. Should be true or false. Okay, so I can set. Depends on the cup of coffee, right? So yeah, I could set this.cream to be true or false, whatever, and if I now log cup of coffee or any object that is created using this function, then I will see that it has cream true. But this is probably something that depends on the cup of coffee. So how can I make this true? How can I make this more dynamic? How can I allow this to be determined at the time that we actually create the cup of coffee by the user? Constructor, using the constructor. Yeah, add it as an argument. Where do I add it as an argument? As a parameter, as an argument of the function. No, not create. What am I doing? Cream. There we go. So if I actually add options to this function, we can pass parameters in as we create new coffee. So if I create a new coffee and I pass in true, this is a cup of coffee with cream. If I create my, I don't know, nasty coffee, it would not have cream. Nasty, nasty. Spelling is one of my strengths, as you can see. So then we now get to kind of modify the object as it's being created. We get to give it the state we want as it's being constructed. So if I log this now, we get 2 cups of coffee, one with cream and one without cream. So this syntax is, I guess, kind of useful a little bit, and it kind of feels like if we ignore this completely and just look at this code, it kind of feels like I'm using classes. If I came from another language that used classes, I'd be like, oh, cool, that looks like I'm creating a new object from a class. Sweet. So JavaScript developers got kind of happy about just using functions as constructor functions. And with this weird kind of hack that happened when we use the new operator and how it creates a new object that we can then manipulate within that constructor function. Okay, any questions about this kind of syntax?
If you wanted to have more than one, would you just create an object within that function and then pass the object as a parameter?
More than one what?
Like this dot cream is true, or whatever. This dot sugar.
All right. So,
Dot
yeah, this dot sugar equals. Let's pass that in as a param. Sugar.
oh, just something that
Yeah, because remember this is just a function that does something a little bit different when we use the new operator. But it's still a function. It still acts like a function. This dot cream, this dot sugar equals sugar. Wait, does it have sugar? Yeah, I'd say like definitely cream, but definitely not sugar. And this bottom one is definitely nasty now. Like who has sugar without cream in their coffee? That's just sugary coffee. Okay, so this is the most basic way I would set up objects using this constructor function. Cool. Where do we want to go from here? So what happens when I want to assign a method to coffee? Right, we've got state here, but what if I wanted, I don't know, what does coffee do? What is the behavior of coffee? Caffeinates, wakes you up, makes you wired. I don't know, so coffee make me wired? Coffee make wired and like put a person in as the parameter? I don't know, coffee, like if you leave it out, it just gets cold. Causes addiction. Anything from Calgary? What does coffee do? I'm waiting for the perfect one. Gets you wired, gets cold. What was that? Diuretic?
Oh yeah. All right, we're using that one. Makes you poop.
Makes you poop. All right, let's see what Dave got. I like makes you poop. I think we should go with makes you poop. My face feel electric. Almost as good as makes you poop. Okay, so coffee dot makes me. So how would I add a method makes me poop to this? This dot make me poop. equals like function? No?
Oh, I see.
Thank you.
You pass in a person that poops.
Nah, we're not gonna get that complicated. We're just gonna, what are we gonna do? Just like console log poop, right? Yeah, because that's what this lecture's all about. Cool, so now, no matter what the coffee is, we should be able to make me poop. Right?
Let's consider a method.
What is a method? Give me the definition of a method in JavaScript.
It's a, yeah, function that
A function that is a property of an object. That is the definition of a method in JavaScript. 100%, yeah. So is this function, yeah, right? Is this function a property of this object? Absolutely. It is the property make me poop. That's the function. Anyway, so let's run this and let's see console log, yay, poop. And look, we can even see, if we're logging coffee, we see that it has cream, sugar, and a make me poop function. Yeah. One thing to take note of, though, is that every coffee gets its own make me poop function. When it comes to state, that makes sense, because look, all this state is different. This has cream, this doesn't, doesn't have sugar, this does. But this function is exactly the same for every coffee. So why are we making copies for every single coffee? So, all right, assign it to a prototype. How do we do that? Or why would that work? What benefit would that give us?
you have to rewrite it all.
There was a lot of pointing in that description. But yeah, let's say we took this make me poop function and put this inside an object and had coffee's prototype be that object. That way, every instance of coffee gets its own version of all this state, but only one make me poop function exists. People walking through this room probably think the weirdest stuff's going on. There is only one make me poop function that exists on this other object, and all these coffee objects, when we ask them to make me poop, they'll be like, whoa, no, I don't know how to make you poop, but let me check with my prototype. And then that function just gets to exist in one place. So instead of copying all this behavior across all these different versions of coffee, we get to just have it in one place, and all those copies can kind of just ask their prototype. Okay, so what we're talking about is assigning gives you heart palpitations. the poop or the coffee. We'll leave that one alone. So what we're talking about is having each instance of coffee, have a prototype that actually has the make me poop function rather than just assigning it to every instance of coffee. By default, when we create a new coffee this way, what is its prototype? I heard object, I heard coffee. Is it coffee? So is cup of coffees, let's see, my question is, if I want to access cup of coffee's, prototype, square bracket, prototype, using .proto, what is that? What is that going to be? So some people said coffee, some people said object. Let's see, if I console log this, I don't think we're going to get anything useful. So is it equal to coffee? Is it equal to object? What is this? This is important. What is, by default, an object's prototype when it is created using a constructor function? Let's take a look. It's neither of those. No, it has a prototype, and we did mention it in the notes. Let's see. It's line 41 of my notes. Not coffee. Coffee.prototype, yeah. Uproar. Yeah, coffee.prototype. Why coffee.prototype? So every time we have a constructor function, or every time we create a function, even if we don't ever use it as a constructor function, it gets a property called prototype. Like, dot prototype, which isn't its prototype, it's just a property called dot prototype, which is an empty object. Every time we create a new object using that constructor function, that object's prototype will be the constructor function's dot prototype.
And so you can't just call dot prototype on the cup of coffee. What would that?
If we call dot prototype on the cup of coffee, oh, dot prototype like this? Dot prototype is a property that only exists on functions. So this would just be nothing. Dot prototype, I think I wrote that, yeah, but I'm going to write it again. Dot prototype only exists on functions. So if you see dot prototype, you are dealing with a function. So this wouldn't work. But we can see, if we just like accept this, okay, every coffee's prototype will be coffee.prototype, then, well, what we're trying to do is add the make poop function to every cup of coffee's prototype. So how would I, instead of attaching make me poop to the coffee itself, how would I attach this to every cup of coffee's prototype object instead? I could do this dot proto, I guess, but that's definitely not the recommended way of doing it. The recommended way you'll see, and the way that you'll be using it today, is to, after you've declared a constructor function, you access that constructor function's dot prototype and just add methods to it that way. This, what you see here, this kind of syntax is extremely common in the JavaScript community, especially before the ES6 class syntax, because this was the way that Joel just walked in and he's looking at our function. And he smiled and nodded, yeah?
Yeah, no, that's about it.
Yeah.
Now that I've stopped looking at the syntax and started looking at like the semantics.
Oh, he was happy with the JavaScript. He's not happy with the subject. Yeah, it's Friday, right? This is how you will see, the object-oriented JavaScript. The people that wanted classes, this is how they programmed their JavaScript before classes came along. So this is a really common syntax to see. Basically, if we were using classes here, this would be class coffee. This would be our actual constructor within the class, and any method that we added to the class is getting added to that function's dot prototype. Yeah, a lot of like confused looks. So why should you know how to do this? Well, sometimes you don't have access to ES6, let's say. I mean, that's uncommon. But sometimes you'll work for a company that doesn't want to use new features, maybe, like classes. Maybe you'll go work for a company that's like, yeah, we do object-oriented programming in JavaScript, but we use ES5 style. Or maybe you'll go work for a company that uses the other way that we saw, where it's just objects connected to other objects without any constructor functions. That's a great question. If you wrote your JavaScript using classes and then you asked Babel to translate it into ES5, what would that look like? Yeah, something like this, close enough to this with a little bit more noise around it, but yeah. Are you at the JavaScript syntax or the actual subject? Don also agrees and walked by swiftly. So yeah, no, if we actually, maybe it'll be really quick, because that would kind of be cool. Is there a Babel, how do you do the Babel? Babel.js, yeah, if I had it wrong, that'd be embarrassing. How do I just want to really quickly go into that REPL and just, it's the link at the bottom, write code here, sweet. So let's say class coffee has a method, whoa. Okay, yeah, so it added way more noise, but make me poop is a method that console.log. Nothing for now. Wow, there is, yeah, 'cause it has to add all this other stuff to make sure everything works. But if we see there's our constructor function. They just wrote it a different way, and we should, oh, yeah, no, they're using really weird syntax. Yeah, I wouldn't look too much into this unless you really want to see How? Well, no, I can't. I can't zoom in. Because it's dealing with enumerable and unenumerable properties, which I'm not going to go over today. But yes, so Babel doesn't do it exactly like that, because Babel tries to take into account every single little detail and make sure that it's really compatible, and they take care of issues that you might encounter in normal JavaScript. But this kind of syntax is kind of what you get when you use the class keyword. This is pretty much what's going on behind the scenes. Another thing, actually, I was using a library really recently to deal with Bluetooth stuff. And it was a Node library that I could install on like a Raspberry Pi just to use Bluetooth. Really great library, did exactly what I wanted it to do, but all of their examples, all of their everything actually, all their code was written in a syntax like this. So had I not known how to actually use prototypes, I would have been like, whoa, where's the classes? Why can't I use this library? So just being able to know about prototypes and what's going on allows you to program in any of those styles when doing object-oriented programming in JavaScript. So I wouldn't write this off because you will see this a lot still. Ocelots. No. No. Again, that other statement, right here, nope, there it is, there, this way. Maybe I should, like, highlight it. There is no correct way of doing OO in JavaScript, meaning, go nuts, do whichever way you want. If you want to use constructor functions, cool. If you want to use classes, cool. If you want to do it the other way with just plain old objects, fine. They are all fine. It isn't like we now have the class keyword, everyone use classes. It's like, no, there's just another way of doing it now. And behind the scenes, this is what's happening anyway. And this actually gives you more power because classes kind of take away a bit of power. No, the question was, are there any other languages that do it this way? Not quite, but you do get dynamic languages that allow you to do things like this. But yeah, this is JavaScript's the only language, only popular language I know of that actually does things with like this. Okay. So let's see. Did we console log that already? Right, cool. Okay, so now you can see that the make me poop does not exist on the coffee itself. It exists on the coffee's prototype, which is coffee.prototype, which is where we added the method. So we can still call it on there because now every copy, if we say, what is it? Make me poop. If we ask a copy to make me poop, it does not have that function, but it just goes to its prototype, which does have that function, and then we're good. Okay? Any questions? Yeah, this one requires a bit of practice and patience with all the prototype stuff. So, let's see, how are we doing for time? Ooh, we're getting towards the end of lecture. So, let's create another file, and we'll go over some... We'll clear up a couple more things. Okay, so what is the difference between creating an object this way and creating an object this way? Think about it. What is the difference between these two? There's pretty much no difference. So when we create an object, we are actually pretty much doing... Oh, wait. I didn't. Whoops. Did that still work, even though I didn't? That's funny. JavaScript. It's like HTML. When like half your HTML is still missing, your page will still render. So... yeah, so there's pretty much no difference between the way these are created. So every time we create an object, we can almost think that we created it this way. Based on what we've learned today, what is object if we use the new operator with it? So what? What do we use the new operator with? Constructor functions. So what is object? Object should be... Whoops. Actually, I might just do this in the REPL. Type of object. Yeah, function. Object is a function because if we're using the new operator with it, it is a function. Has anyone created an array this way? But you know you can. But what would array be then if I can do this? It would have to be a function, yeah. Type of array function. I should say type of isn't completely reliable, but it's good enough for this example. That isn't true. That's just type of being weird. But yeah, no, it's good enough for my example. These are in fact functions. So what do we know about constructor functions? Right? If we use them with the new operator, they are functions like constructor functions. Every function gets a property. What property does every function get? Prototype, right? So what is, in this case, object.prototype? It's an object. It's an object that when we create an object using this constructor function, that object's prototype becomes that object. It's like trying to explain this. You're like this, this, and this, this. So this object's prototype will be object.prototype. What will this object's prototype be? Object.prototype. So whatever object.prototype is what every object's prototype is when we create any empty object, when we create any object that isn't an instance of something else. So every time I create an object like this, its prototype is object.prototype. So object.prototype is an empty object. What is objects.prototype's prototype? Yo. Because .prototype is a property that only exists on functions that points to an object that, I don't want to wordy stuff again. This only exists on functions. And it is what, if you create an instance of an object using that function as a constructor function, that object's prototype will be that function .prototype. Objects get a double under proto, which is their prototype. So objects double under proto is their prototype. No, because if I say an object dot underscore underscore proto, I'm looking at that object's prototype. When I say function dot prototype, that isn't the function's prototype. It's an object's prototype when invoked using that function as a constructor function. Yeah, I know.
That was a lot of words.
It's so many words.
That was just words.
Yeah. So every function has a dot prototype, and that is not that function's prototype. It isn't actually anything's prototype except for an object that gets created from that constructor function. It's just like just practice it. Like take that like, oh my god, why, and go and practice, and then like at some point you'll be like, oh, I get it. That is named badly. Yeah. Okay. I'm gonna start handing you the rest a little bit more. So if I create a brand new object and I check its prototype, it should be equal to objects.prototype. Because JavaScript. Sometimes when you try and use the REPL. Boom. Okay. So if I create a brand new object, its prototype is object.prototype. Okay. If I check object.prototype's prototype, it's null. So if I create a brand new empty object, it has a prototype that is object.prototype. And that object's prototype is null, so that's the end of the chain. That's the end. So if I create another object, let's say array, and array is like superclass or prototype is object, we'd get this prototype chain that goes from like arrays to objects to eventually null. So usually we pass through object.prototype and then we get to null. And that's the end of the chain. That's why when I call a method that doesn't exist anywhere, we get that error, because it's trying to call it on null. Now, what this means is that object.prototype should contain all those methods that we talked about earlier, toString and those other ones. So if I ask object.getOwnProperties of object.prototype, that isn't how you call that. GetOwn, how do I say that method? Object.getOwnPropertyNames. As for all the property names of object.prototype, we see there's toString, value of, proto. That's where they hide. And like I said, there's not that many. Yeah. But that's why when we call methods that actually don't exist in any of our objects, but we can still call them, like toString, it's because they exist in object.prototype. And usually that's where our prototype ends up going before it hits null and before our app crashes because it couldn't find anything in there.
So these are only for objects. Specifically.
Yeah.
For the methods.
So any object, when I create it, gets a prototype by default that is object.prototype, and that's why I can call toString on an object even when I've only just created it.
Yeah.
Because that object gets created, it gets a prototype that is object.prototype that has toString, so I can call toString on it. No. That the getOwnProperty names gives me an array of all of these. Every function gets a prototype property that is an object. Prototypes are always objects, so objects linked to other objects. Yeah. Fun stuff. Okay.
What you say is like a sentence and a half is like usually what we should get out of understandable.
How does property lookup work in JavaScript?
So basically understanding that lead.
Yes. If you understand that, great. Cool. The rest is just kind of syntax that you will have to practice before it sinks in. But if you get, okay, so it's just an object linked to another object, and like that object has a prototype, so if that doesn't have the property that I'm asking for, it's going to ask its prototype for that. And if that doesn't have it, it's going to ask its prototype, and at some point it will probably end up at null, which, you know.
So does that list would have prototypes of both individual?
You kind of asked a quarter of a question, so no.
Sorry, in that array that you showed us with all the other.
So these are the properties of object.prototype.
I mean, those are individual properties of that array.
These are all properties that exist on object.prototype. So if you call any of these on any object, it should work because it exists in object.prototype, which is prototype.
But this is like the end of the line. Kind of thing.
Exactly.
That's what I was trying to ask.
Yeah, so it's the end of the line, yeah.
Okay. This is the last part.
That's the last part. End of the line.
End of the line. Right?
Okay. How are we doing for time? 10:51. I'm gonna go right up to 11 with this one. So, yeah. What else can I try to bring to? Who has ever gone to the MDN docs for for JavaScript stuff? Yeah. Who's ever tried to look up something, I don't know, like array.sort? Yeah, and who's ever looked? Where's MDN? There it is. Who's ever looked and seen, oh, it's like array.prototype.sort. Oh, whatever, I'll just ignore that. How does sort work?
Yep. Always.
Every single time. Okay, so let's break this down a little bit. If array has a property called .prototype, what does that make array? A function. A function with a capital letter at the front and a prototype that's used, so we should probably use it as a constructor function, so new array. Or we can just use the square brackets, that's easier. Where does sort exist?
In that array.
It exists on the arrays.prototype object, which means any instance of array. Let's get rid of that. Let's see, any instance of array I can call sort on. But let me just call that. Sweet. But if I was to look at object.getOwnProperty names of an array, so the array actually does have the .length property that is on each instance. But array actually doesn't have anything except for length. But we can call .sort, .filter, .map, .forEach, all that stuff on an array. And every time we look at how to use one of those functions, we see, oh, it's array.prototype. Every time we create an array, that object has a prototype that is array function.prototype. So any methods that exist on array.prototype are methods that an array can use through its prototype. It's like we ask an array, hey, do you have a .sort property? And it says no, but let me check my prototype, and the prototype does in fact have sort. So if we were to look at the prototype of array, there's everything we can call an array. Because every instance of array doesn't actually need the exact same pop, push, shift, unshift, slice, keys, map, whatever. They all use the exact same one that just exists in array.prototype. What are some built-in JavaScript? Other built-in JavaScript objects. I don't know, has anyone got a good built-in? Huh? Date, map,
Yeah, which map will you suppose?
new date. So if I created an instance of date, you just do date stuff. But because it's a function, it would have that prototype, which we could look at the keys of and see exactly what you can do with a date. So let's see. What methods exist on a date? Wow. Yeah, just go straight to the construct functions prototype to actually see all the methods though.
Do you think that toString is actually in that array, or is it referencing?
No, toString is in object.prototype. So if we looked at date.prototype, all right, I'm making a guess here, but I think date.prototype.
Only one date, or is there many? Or sorry, is there only one toString, or is there many toStrings?
There's only one, unless you created another one.
Oh. Whoa. Okay.
Yeah, okay.
So there's only one. Oh, sorry, toString. There's only one.
Unless I created a toString, you know,
Well,
like if I created a
this
thing.
object, or this.
The joke was, if I created another toString, wouldn't it be a 3-string? Okay. You are going to have assignments today.
Oh gosh. Okay.
You are going to have assignments today. Yeah, if we had more time, we could like talk about this. I know everyone loves this. You're going to have assignments today where you're going to have to write code like this. So if you like thinking about stuff like classes, then you're going to create a class with the keyword function instead of class, and you're going to add methods to that class.prototype. Or you know, you can just think of it as a construct function that has the .prototype and everything else we talked about.
I get the properties named on date.prototype. Those are the methods within date prototype, not object. That was kind of a difference.
That was, so the question was if I get get own property names of date.prototype, those are all the methods that I can call on any instance of date or anything that at some point has a prototype that points to date.prototype. Objects never points back to date.
Okay.
So you could not call any of those on a standard object that doesn't in fact point to date at some point in its prototype chain.
When I do that, when I get a property named date.prototype, there is a toString method.
Ah, sweet. Where is it? Okay, so when you get own property names of nice. Okay, when you get own property names of date, you do see actually a toString. No, and actually this question was kind of asked and I kind of brushed it off and I shouldn't have. So toString, when we call it on an object, we get that kind of object-object thing, which is kind of not great, right? Like, we wouldn't want that for every single object. So what objects can do is override this toString, which really just means implement their own toString method to give us a better output. In this case, date will actually give us like a nice date string rather than just the object-object string. And this doesn't really affect anything we know about how property lookup works. If, in fact, we did add a quack method to potato, if we did that, though, and we asked the potato to quack, potato would just be like, yeah, of course I have a quack method. Here, use this one. And it would never make its way up the chain, right? So if we added a toString to potato that returned a potato emoji, then as soon as we ask it for toString, it returns a potato emoji, and it never makes its way to object.prototype to get that toString. So yeah, any object can implement any method that's already defined somewhere in the prototype chain. It just means that if we ask that object for that property, it's like, yeah, I have it, so let's not ask my prototype. Be like me having a pen. You know, you ask me for a pen, and I'm like, yeah, here it is. I'm not even going to bother asking Joel. So this is actually a pretty common thing to do because seeing object printout is awful, whereas like we would actually like to see maybe a potato emoji or maybe a nicely formatted date string.
So if you erase that method, you would get object, and you want date.prototype.
If I erase that method, would I get object instead of yeah, let's check that. Okay, so I'm going to delete date.prototype.toString. And then we're going to create a new date, and then we're going to say dates to string. What's going to happen? I'm expecting object, but let's see. Okay, so node 4. Whoops. Oh, I'm inside the REPL still. Node 4. Yeah, object. Oh, object date, whatever. Yeah, because it says the type. Which is like useless. Whereas if I hadn't deleted date's version of it, we would see a nicely formatted date. So anywhere you can implement your own version of other methods, and it just means that that one gets used because it's first in the prototype chain.
Oh, you just named the thing.
I deleted it, but
Yeah, that's not the same toString as the one that's inside that array. Is that what you said?
that's not the same toString that exists on object. Yeah.
Is it logging object date just wrapping date in an object wrapper and then toString in an object wrapper?
No, date is an object. So we just call that method on it. One thing that hasn't really been brought up, and Calgary's been kind of quiet since heart palpitations, but you know, yeah, sure, we can delete toString and all that stuff, but let's say, you know, I don't know, my array for each doesn't quite for each the way I want it to. I prefer if it would like do it backwards or start from the middle and then kind of just randomly jump around. I don't know, something weird. You know, you could just say array.prototype.sams for each equals, and then Sam's for each just returns like jazz hands, because why not? Now if I create an array, I just say Sam's for each. And it's useless, but whatever. Or maybe, oh, yeah, okay, so maybe it returns, maybe it actually maps the array. So return this dot map, so it maps the current array to just a bunch of jazz hands. Yeah, so actually just call this like jazzy. So if we make an array jazzy, it just maps everything to jazz hands. So if we take an array of 1, 2, 3, 4, it's just going to be jazz, 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 jazz. That'll be fun, right? Yeah. And if I included this in every project, because I've just added it to the arrays prototype, every single array that's ever created has a prototype that is array.prototype. So by modifying this object, every array gets this functionality. If I actually added this to object, this is bad, by the way, don't do it this way, because this will now be an enumerator property that will show up in like for loops and stuff. There are ways of getting around that though if you really wanted to do it. But now this .map wouldn't work. But maybe I could just like create an array of size like 20 and map it to, will that work? I don't know. The point being, I want to be able to create any object, call Jazzy, and get 20 jazz hands back from it. We don't have to, because they did some funky stuff in the function, which isn't that difficult to do. You can create your own constructor functions that act as constructor functions without the new keyword by manually going in there and doing some stuff. You basically at the top of the function say, hey, was this called with new? Oh, let's actually return this function called with new. It's a weird hack that allows you to do it with array, error, object, a couple of others. 20 empty items? That's annoying. Oh, right, you can't do that. You know what, it's just going to return jazz hands.
Oh, yeah, good.
What? Yeah, cool, whatever. I can now call object.jazzy on whatever I want.
Could you name Jazzy, instead of having Jazzy, if you call that for each, would that work still?
Yeah, absolutely, except if you had an array, it would use the arrays for each, because arrays for each would come before that.
Right. But if it didn't, this one would be the new for each.
Yeah, so let's say I did array.prototype, because this is more applicable. Yeah, I've now overridden what arrays for each was. So I could really screw some people over, like go into their code and just like inject this somewhere, and they're like, why is my for each not working? It just returns jazz hands. Yeah, exactly.
Oh my god.
If you only knew how to use classes, you wouldn't know what's going on here. You wouldn't be able to do this. Okay, so you don't get as much power with classes. Because I know how prototypes work and everything going on under the hood in JavaScript, this allows me to program in much different ways, or in every object-oriented way. Okay. So that's time. It's 11:03. Key takeaways: how does property lookup work in JavaScript? It's objects linked to other objects. It's that simple. This syntax that we see in 3 right here, this is good to practice and become a little bit more comfortable with. And today you're going to do that, just so that when you see it in the real world, and you will see it, it isn't completely like, whoa, what is prototype.make-me-poop? And you're like, oh, I know exactly what that does. Just makes you poop, right? But key takeaway, yeah, it is prototypes in JavaScript. When it comes to next week, you guys will be using Ruby. You use classes. Classes are a big deal in Ruby, and they work the way you'd expect them to. Just in JavaScript, it's a little bit different. So be comfortable knowing that in JavaScript, you might see some weird stuff. But I think you're already comfortable with that, right? JavaScript's a bit weird, right? Like, I know I already did this one, but type of null is object. You know, 1 divided by 0 is infinity.
What?
0 divided by 0 is nan. Type of nan is number, even though it's not a number. Yeah, anyway, I could do a whole lecture on this. But, wait, one more. I'm going to leave with this. I think this will do what I want. I might need a couple of tries at this, but if it works first try, awesome. Damn it. Why did that not work? Maybe I need to put parentheses around this? Yes! Okay, all right. Any questions? Cool, okay.